Hello class, Professor Small. My name is Edie Waldsmith. My reflection presentation is on antibiotics. Antibiotics are a technology developed and used to treat infectious diseases in the human body caused by harmful strains of bacteria. Inarguably, antibiotics are one of mankind's greatest medical inventions. Early civilizations used antimicrobials or molds to treat infections. But it wasn't until 1928 that a Scottish bacteriologist by the name of Alexander Fleming accidentally discovered the antibiotic penicillin. While working in his lab, Alexander noticed that a fungus had contaminated a culture plate of Staphylococcus. Upon further inspection, he noticed that the Staphylococcus kept a safe distance from the fungus. Alexander identified the fungus as Penicillium notatum. With the help of two other scientists, Howard Florey and Ernest Chain, the antibiotic penicillin was produced. In 1945, the trio won the Nobel Prize and Alexander was knighted. His famous quote, "One sometimes finds what one is not looking for," describes his discovery. Penicillin was considered a miracle drug and was mass-produced during World War II. For the first time in the history of war, there was a sharp decline in loss of life due to infection from wounds. Limbs that would have been amputated due to the infection gangrene could now be saved with penicillin. It didn't take long for scientists to realize that some bacteria became resistant to penicillin, and so new antibiotics were developed and produced. With these new antibiotics, scientists were able to eradicate infectious diseases like tuberculosis, polio, smallpox, syphilis, and gonorrhea. I know you're wondering, wow, how do antibiotics work? Antibiotics are either bactericidal or bacteriostatic. Cidal means to kill, static means to stop. Bactericidal antibiotics kill the bacteria by interfering with the formation of the bacteria's cell wall or its cell content. A bacteriostatic antibiotic stops bacteria from multiplying by interfering with bacterial protein production or DNA replication. Antibiotics are further characterized as narrow or broad spectrum. Now I'm going to talk about antibiotic resistance. Drug-resistant bacteria are an example of evolution in action. Darwinian evolution states that only the fittest will survive. Superbugs are the fittest of the harmful bacteria that have managed to evolve and develop antibiotic resistance. Since the discovery and production of antibiotics some 90 years ago, humans have steadily overused and abused them. This is a real health crisis that affects everyone, not just the sick, because the most dangerous strains of bacteria have developed a resistance to our most powerful antibiotics. Imagine going to the hospital for a simple procedure only to find out that you've caught a skin infection like MRSA, which is a dangerous strain of staph bacteria that could potentially end your life. It is a prospect that is all too real and needs to be taken seriously. Today, the economic cost of treating drug-resistant infection is about $20 billion per year. It is reported that 700,000 people die every year from infection due to antibiotic-resistant bacteria. And if we don't stop the abuse and overuse, it is estimated that by 2050, the loss of life will grow to 10 million people per year. How can we prevent this? Physicians must only prescribe antibiotics for bacterial-related illnesses and not viral. Antibiotics do not work on viral infections. Patients must finish the full prescription prescribed by their physician. Farmers need to stop putting antibiotics in their animals' feed and instead vaccinate their livestock against disease. It is estimated that 70% of all antibiotics are used on farm animals. Ultimately, antibiotic resistance prevention rests in education and public awareness. Scientists are working hard on alternative ways to treat infection. New antibiotics are being developed that specifically target harmful bacteria without hurting the beneficial bacteria that make up our microbiome. The impact antibiotics have on our lives in regards to fighting infection in the human body has been immeasurable. But the future of antibiotics in fighting infection is uncertain, and it is a battle that needs to be fought on many fronts. Thank you.